Imagine a digital bouncer, right? Like this guy at the door who doesn't just check your ID card, but actually acts as a psychic detective.
Right, a psychic bouncer.
Exactly, like predicting a cybercrime. Before you even reach for the door handle, welcome to the WeCyberYou Unlocked podcast. We are absolutely thrilled to have you here with us today.
We really are. It is great to be here.
And for this deep dive, our mission is to explore this massive stack of notes and research we have from a really fascinating article. It's called The Evolution of Intelligence, a deep dive into AI firewalls.
Which is such a great title for what is happening right now in the industry.
It really is. Because, look, if you are listening to this right now, you probably already know that the cybersecurity landscape is just, shifting beneath our feet every single day.
Oh, absolutely. Daily, hourly, even.
Yeah. But the changes happening in firewall technology specifically right now, they're on a completely different level. We are looking at systems that have evolved from those basic digital bouncers we talked about into these highly autonomous analytical engines.
That is the core of what we are looking at today. And it's great to synthesize this with you because we are not just talking about like a shiny new gadget here.
Right, or just another minor software update.
Exactly. We are examining a fundamental transformation in how organizations protect their networks against incredibly sophisticated threats.
It's huge.
It is. We're moving away from this whole world of static, rule-based security and stepping into a reality of intelligent, adaptive security. I mean, in the modern threat landscape, that transition has gone from being a luxury to an absolute necessity.
Okay, let's unpack this. Because to really appreciate why artificial intelligence is so necessary right now, I think we first need a quick flyover of what exactly it is replacing.
Yeah, that makes sense. Context is everything here.
Right, so you and I know the basics, but the source material outlines 4 distinct generations of firewalls. Let's condense those early days a bit.
Yeah.
How do we get from a basic locked door to this psychic detective?
Well, the first 3 generations are essentially just variations of that bouncer analogy you brought up. So generation 1 is packet filtering.
It's just the absolute basics.
Exactly. It just checks IPs and ports. It asks, does the packet match the rule? If yes, allow it in. If no, block it. Very straightforward.
Right, like checking if your name is on the clipboard.
Yeah, exactly. Then generation 2 brought us stateful inspection, and that added connection tracking.
So it remembers you.
Right. The system remembers that you already authenticated a few minutes ago, so it's not asking for your ID every single time you walk past the door.
That makes sense. Okay, and generation 3.
Generation 3 is where we got application-aware firewalls. This introduced deep packet inspection and user identity.
Oh, so it's actually looking at what you're doing.
It is. It started asking, what application is generating this traffic? Like, is this a normal web browser? Or is it malicious code that's just disguised as web traffic?
Okay, got it. So generation 3 is basically a very thorough security guard. They are checking the VIP list, they're remembering faces, and they're actually looking at what the guests are wearing to make sure they belong at that specific party.
To a degree, yes. But that bouncer analogy actually breaks down completely when we hit generation 4.
Oh, really? Why is that?
Because the problem with those first 3 generations is that they all still rely on static rules.
Right, they need to be told what to look for.
Yes. Predefined policies, known attack signatures, they are fundamentally backward-looking systems.
So they can only catch things that security researchers already know are bad.
Exactly. Generation 4, which is the AI-Powered Firewall, is a total paradigm shift because it completely abandons that reliance on static rules.
It just throws the rules out the window.
Well, it introduces machine learning, behavioral analytics, and autonomous response. So the core decision completely changes. Instead of asking, is a rule being broken? The firewall asks, is this behavior normal or is it indicative of an attack?
Wow. That is a massive leap in logic. So instead of looking for, I don't know, a cartoonish villain with a crowbar trying to smash a window.
Right, which would be an obvious known threat.
Yeah, exactly. Instead of that, it is more like credit card fraud detection. It's looking for statistical anomalies.
That's a great way to put it.
Like, it doesn't need a specific rule that says no crowbars allowed at 3 a.m. It just needs to know that this specific user has never, ever engaged in this specific sequence of actions before, especially not at 3 in the morning while sweating profusely.
Yeah, that is a much more accurate way to understand it. The Generation 4 firewall evaluates the entirety of the context, dynamically weighing probabilities.
It's doing math in real time.
Tons of it. It evaluates the situation the same way an experienced human fraud investigator would, but it executes that analysis at a scale and speed that no human could ever possibly match.
Okay, so that leads us to a really crucial question. If this Generation 4 system relies so heavily on knowing what normal looks like, in order to spot those statistical anomalies, how does it actually figure that out?
That's the big question.
Right, because no human programmer sitting there typing out a normal baseline for thousands of employees manually. That would take years.
What's fascinating here is how the source material breaks down the core trio of technologies that drive this capability. We are talking about artificial intelligence, machine learning, and behavioral analytics.
The big three. Let's look at the mechanics of that.
Sure. So artificial intelligence enables the system to evaluate context and probability simultaneously. It uses these complex, multi-dimensional vector matrices.
Multi-dimensional vector matrices. Say that 5 times fast.
I know, it sounds very sci-fi. But practically, rather than following a rigid if-then logic tree, the AI plots user actions as data points on a complex graph.
Just plotting them out to see where they fall.
Right. It does that to determine if an event falls outside the safe cluster.
So it is calculating probabilistic risk based on 100 different environmental factors all at once.
Exactly. And then the second pillar, machine learning, is what allows those models to actually improve over time.
Without human help.
Yes. Instead of waiting for a security vendor to, send down a manual update for a new virus signature, the ML algorithms ingest historical data on their own.
So they just eat up all this background info.
They consume vast amounts of information. Past attacks, normal network traffic, cloud workloads, device communications, you name it.
Okay, and then the third pillar is behavioral analytics, which is the actual art of baselining. This is where we actually define what normal is.
Right.
It is almost like the system is creating an invisible biometric fingerprint for every single user and every server on the network.
That biometric fingerprint concept is highly relevant here. The sources give some very concrete examples of how granular this actually gets.
Let's hear them.
For instance, the firewall learns that a normal employee typically logs in between 8:00 a.m. and 6:00 p.m.
Okay, pretty standard business hours.
Right, and it learns they generally only access the finance databases, and they usually download fewer than 20 files a day.
That's their fingerprint. And it does this for the hardware too, right?
It does.
Because the text mentioned that a normal server might only communicate with specific database servers. It only transfers backup data overnight, and it uses HTTPS encryption exclusively.
Exactly. The servers have fingerprints just like the human users do.
So if we take that normal finance user, and suddenly they log in at 2:00 a.m.
Which is way outside their 8 to 6 window.
Right. And they try to pull a massive directory from the HR database instead of finance. The firewall just throws a massive red flag.
Yes, instantly, even if their username and password are correct.
Really? Even with the right password?
Absolutely. The credentials might be perfectly valid, but the behavior deviates so sharply from their established fingerprint that the probabilistic risk percentage just skyrockets.
Okay, let's take this from theory into practice for you listening. Because if I'm a threat actor trying to breach a network right now, how does this system actually catch me in real time?
The research lays out a 6-step playbook that acts as, well, the anatomy of a catch.
Let's walk through that workflow, step by step.
It begins with step 1, data collection, and step 2, baseline learning. Now, the sheer volume of telemetry involved here is staggering.
Because it's watching everything.
Everything.
Yeah.
The firewall pulls data from network packet flows, operating systems, cloud containers, user authentication events, global threat intelligence feeds.
It's a fire hose of data.
It is. The text notes that large enterprises may generate millions or even billions of security events every single day.
Millions or billions of events a day. I mean, that is just an unfathomable amount of noise.
You couldn't process it manually if you tried.
No. You could have a room full of 1,000 human security analysts just staring at monitors, and they would never be able to parse that volume of data.
Which is exactly why the AI engine is required to process it all. During the baselining phase, the system takes all those billions of events and builds the behavioral profiles we just discussed.
Right, the fingerprints.
Yes. It takes time to learn that Sarah logs in from Sydney during business hours, or that the payroll software only talks to 3 specific internal systems.
Well, here's where it gets really interesting. Because once that baseline is fully baked in, we move to step 3 and step 4, which are continuous monitoring and anomaly detection.
That's where the magic happens.
Right. The firewall is constantly cross-referencing every single new event against those historical baseline graphs. So if Sarah opens Microsoft Outlook to check her email, that aligns perfectly with her historical cluster. The system just stays quiet.
It doesn't bother anyone.
But if Sarah suddenly downloads 40 gigabytes of confidential design files, the machine learning flags the deviation immediately.
And the source material highlights some specific anomalies that machine learning is uniquely suited to catch. Things that legacy firewalls just completely miss.
What's a good example of that?
One of the most common is lateral movement. This is when a workstation that normally just handles, say, word processing, suddenly begins scanning hundreds of internal IP addresses.
Oh, wow.
Yeah, it's just probing the network for open ports.
That is a massive red flag. The machine shouldn't care about anything other than its own standard connections.
Exactly. It has no business looking around the network like that.
Another one from the text that I really loved is impossible travel. It is such a simple concept, but incredibly hard for legacy rules to catch.
It really is.
So let's say Sarah logs into the network from Sydney, Australia at 9:00 a.m.
Okay.
Then at 9:15 a.m., Sarah's exact same credentials are used to log in from London.
Right.
The AI instantly flags this because it calculates the geographical distance, the speed of light, and the time between authentications. And it realizes it is physically impossible for a human being to travel from Sydney to London in 15 minutes.
That is a perfect example of mathematical probability overriding legitimate credentials. It does not matter if the password was correct.
Or if multi-factor authentication was somehow bypassed.
Exactly. The physics dictate that the account is compromised, period.
It's just undeniable math.
It is. Another classic anomaly mentioned in the text is beaconing.
Oh, beaconing. That sounds ominous.
It is. This is when an endpoint starts communicating with an unknown external IP address on a rigid mathematical schedule, say exactly every 300 seconds.
Right, because humans do not browse the web on a perfect 300-second interval.
We don't click reload with a stopwatch.
Right.
The text notes that this specific behavior is a hallmark of command and control, or C2, malware. It is the infected machine basically calling home to the attacker's server, just waiting for instructions.
And a normal firewall would miss that.
Often, yes. A legacy firewall might look at the traffic, see that it is just a tiny encrypted packet over standard web ports, and just let it through.
Because no static rule was broken.
Exactly. But the AI firewall sees the rigid frequency and recognizes the underlying pattern of malware.
So what does this all mean for the workflow? The AI has spotted the lateral movement, or Sarah's impossible travel, or the rigid beaconing. What happens next?
Well, now we are at steps 5 and 6. Threat scoring and automated response.
Okay, break those down for me.
Step 5 is where the system calculates that probabilistic risk percentage we mentioned earlier. It doesn't treat every anomaly equally.
Right, context matters.
Exactly. A 2.0 AM login might be unusual, but on its own, it might only get a low-risk score of, say, 20 out of 100. Maybe the employee is just working late to finish a project.
But a 2.0 AM login, coming from a new IP address, combined with a sudden attempt to encrypt files.
That combination of factors pushes the threat score up to a high-risk 95, and that instantly triggers step 6, which is the automated response. The firewall doesn't just send an email alert to a human analyst and wait for them to finish their coffee and investigate.
Because by then, the damage is done.
Exactly. Depending on the organization's predefined playbook, the firewall can actively block the malicious traffic, tear down the active sessions, or even completely isolate the infected device from the rest of the network at the switch level.
Just cut it off completely.
Yes.
And the most staggering part to me is the speed of execution. The text emphasizes that modern systems perform these containment actions in sub-second timeframes.
Sub-second. It's incredible.
By the time a human analyst pager even goes off to tell them an attack was attempted, the AI firewall has already identified it, sugored it, blocked it, and quarantined the compromised machine.
It is a level of velocity that fundamentally alters the defensive posture of an organization. It changes the whole game.
It honestly sounds infallible when you lay out the mechanics like that.
Yeah.
But I have to push back here, because nothing in technology is perfect.
No, definitely not.
I want to look at the superpowers versus the kryptonite. The superpowers are very clear based on the text. We have user and entity behavior analytics, or UEBA, which is fantastic for catching insider threats or compromised accounts.
Absolutely.
We have predictive detection that spots attacks based on math before a virus signature even exists. And the text even highlights generative AI assistance.
Yes. The generative AI aspect is a massive operational improvement for security operations centers.
How so?
While these large language models integrate directly with the firewall to explain complex security alerts in plain English.
Which has to be a huge relief for the analysts.
Oh, it drastically reduces alert fatigue. Instead of an analyst staring at a wall of cryptic JSON logs and hex codes, the generative AI provides a clear summary.
Like a cheat sheet.
Yeah. It just says, we isolated Sarah's machine because it attempted an impossible travel login from London and subsequently tried to access the HR database.
But that actually leads right into my concern.
What's that?
If the system is this incredibly autonomous, right? If it learns the baseline itself, calculates the probability, scores the threat, kills the session in milliseconds, and then uses a language model to write up a plain English report about what it did.
I see where you're going with this.
Why do we need human security teams at all? Is this replacing the human element entirely?
If we connect this to the bigger picture, we really have to look closely at the limitations explicitly outlined in our sources. AI firewalls are incredibly powerful tools, but they are absolutely not a silver bullet.
They have blind spots.
They come with severe vulnerabilities. The first major limitation is data quality. An AI model is completely dependent on the data it uses during that baseline learning phase.
Garbage in, garbage out.
Exactly. If the training data is of poor quality, the resulting detection accuracy will be terrible.
Wait, let me stop you there. So if a company buys one of these incredibly expensive AI firewalls and they plug it into a network that is already compromised by a threat actor,
Yes.
does the firewall just learn that the hacker's behavior is the normal baseline?
That is a very real danger. It's often referred to as data poisoning or baselining a compromised environment. If the attacker is already inside, moving laterally and exfiltrating data slowly while the AI is in step 2, learning the network, the algorithm will accept those malicious actions as part of the daily routine.
That is terrifying.
Yeah.
It will literally train itself to ignore the attacker.
It will. That is a huge blind spot, which leads to the second limitation, adversarial AI.
AI fighting AI.
Essentially. The threat actors are well aware of how these defensive models work, and they are not standing still. They are actively using their own offensive artificial intelligence to figure out how to evade detection.
How do they do that?
They use algorithms to deliberately manipulate the machine learning models of the defenders. They introduce these subtle, slow-drip anomalies to slowly shift the firewall's understanding of what is normal over time.
So they basically boil the frog.
That's a perfect analogy.
They use their own AI to slowly stretch the defender's baseline until the malicious activity perfectly blends in with the background noise. It is quite literally an arms race.
An incredibly resource-intensive arms race, which brings us to the third limitation.
The cost.
The processing cost, yes. Running these multi-dimensional vector matrices and processing billions of events in real time demands substantial computing power, massive data storage, and highly specialized engineering expertise to maintain.
It's a heavy lift for any IT department.
Very heavy. And I imagine that brings us back to the human element, which answers your earlier question about replacing analysts.
Right. So we still need people.
Exactly. The source text is unambiguous about this. Human oversight remains essential. AI augments human capabilities. It does not replace them.
Because someone has to watch the watcher.
Yes. We still desperately need experienced security professionals to validate those generative AI alerts, to recognize when a baseline has been poisoned, to conduct deep forensic investigations into the incidents.
And to step in when the AI gets confused.
Right. And most importantly, to make the high-impact strategic decisions that an algorithm just lacks the context to make.
So to go back to the earlier analogy, the AI acts as the tireless, hyper-analytical detective doing the massive data legwork in milliseconds.
Yes.
But the human is still the police chief who has to look at the findings, understand the broader business context, and decide how to actually handle the fallout of the case.
That dynamic is exactly how the system is designed to function.
Okay, so bringing this all together for you listening, where is this technology heading next? Like, what does the future outlook for network defense actually look like, according to the research?
The research indicates that the next generation of these firewalls will become even more deeply integrated into the broader security ecosystem.
So they won't just be standalone boxes anymore?
No, not at all. We are going to see seamless, native integration with zero trust architectures, XDR, which stands for Extended Detection and Response, and SR platforms.
And for those who might not work with SR daily, that stands for Security Orchestration, Automation, and Response. It is essentially the platform that executes the automated playbooks across the entire company, right?
Correct. The SR platform actively talks to the AI firewall. So the AI detects the anomaly, calculates the risk, and then triggers the SR platform to not just block a port, but to simultaneously revoke the user's cloud access, quarantine their physical laptop, and wipe their mobile device authentication tokens.
Wow. All in one orchestrated move.
Yes. The ultimate goal is for the AI to proactively map out potential attack paths and neutralize them across dozens of different tools with minimal human intervention.
It really is a complete fundamental shift from the static rules of the past.
It changes everything.
And honestly, it leaves me with one incredibly provocative thought based on what you mentioned earlier about adversarial AI.
What's that?
Well, if these defensive AI firewalls are constantly learning, analyzing, and redefining what normal human behavior looks like in order to protect the network,
Right.
and the offensive AI attackers are constantly learning and calculating how to perfectly mimic that normal human behavior to bypass the firewalls.
Yeah, you see the collision course there.
Exactly. Will the future of cyber warfare eventually just be two incredibly complex algorithms endlessly arguing with each other in the dark over what a human would actually do?
Wow, that raises an important question about the limits of machine logic. It is definitely a thought that will keep security engineers awake at night.
It really will. We want to thank you so much for joining us on this deep dive. To make sure you never miss an exploration into the rapidly shifting landscape of technology and security, please make sure you follow the channel.
We truly appreciate you spending your time and exploring these concepts with us today.
And for more content, resources, and deep dives just like this one, you have to go visit WeCyberYou.com. We have so much more to share with you there. Until next time, stay safe and stay curious.